If you are studying physics but struggling, the problem might not be the physics, but the mathematics behind it. Welcome to Math Physics Bridge. In this video, I'll show you key areas in mathematics that every physics student should master to understand physics. Let's first look at algebra. Algebra is a branch of mathematics that uses symbols and variables like x and y to represent an unknown values. Algebra helps us to solve equations and understand the relationship between quantities. Why algebra matters? In physics, algebra is essential because many physics formulas need to be rearranged before solving physics problems. Example, the kinematic equation v squared is equal to u squared plus 2as. You may need to make acceleration a the subject depending on the equation. Without algebra, we cannot manipulate equations or solve for unknown. So, algebra is the key or the foundation for solving physics problems. But solving equations is not enough. In physics, many quantities have directions. That brings us to the next topic. That's what? Vectors. Vector is any quantity that have both magnitude and direction. Examples include displacement, velocity, force, etc. Vectors can be added, subtracted, or even resolved into components. Why vectors matters? Vectors matters because in physics, many physical quantities act in different directions at the same time. By using vectors, we can combine them or break them into simpler parts for analysis. To break vectors into components, we need a very powerful mathematical tool called trigonometry. Trigonometry studies the relationship between angles and sides of triangles. It helps us connect directions with magnitude using the trigonometry ratios sine, cosine, and tangent. Trigonometry allows us to resolve motion and forces into vertical and horizontal components. This makes complex concepts become easier to analyze. But physics is not just about direction, it is also about change. That leads us to one of the most important topics, calculus. Calculus is mathematics of change and accumulation. It helps us answer two key questions. One is how fast something is changing and how much has been accumulated over time. The derivative gives us rate of change. Example is velocity from position. And the integration gives us the accumulation. Example is work, area, displacement. So instead of memorizing formulas, calculus helps us to really understand how things actually changes. Now, one of the best ways to visualize these changes is through graphs. So we are going to talk about graph interpretation. Graph interpretation is the ability to understand information from a graph. In physics, graph shows how quantities changes over time. The slope of a graph represents derivative or rate of change, whilst the area accumulated under a graph represents what? Integration. Now, for example, from a velocity time graph, the slope gives us what? Acceleration, whilst the area accumulated under the graph gives us what? The displacement, or let's say the distance. Graphs help us to visualize physical changes clearly. Finally, all these ideas are built on one but very important foundation. That is what? Basic geometry. Basic geometry is the study of sides, shapes, and angles. Basic geometry helps us understand space and how objects are arranged. In physics, basic geometry is used in motion, optics, and measurement. Angles, shapes, distance help us to analyze physical systems and solve problems. I want you to have this in mind. Physics is not separate from mathematics, but rather mathematics is the language that describes the physical reality. Master these topics and physics will stop being difficult and start making sense. If you really want to understand physics, not just memorizing formulas, Then follow our channel, Mars Physics Bridge. And don't forget to like and comment. This is Mars Physics Bridge, and I am Sir Rich, your guide. See you next time.